Good morning, my dear students. We are here today to cover Unit 2, Lesson 1 with you, your science teacher, Miss Salma Kamel. Let's go to slide 2. We need energy in different fields in our life. As we know from previous that energy is the ability to do work or make change. And the measuring unit of energy is joule. Okay, now we'll talk about the energy in our life. We provide cars with fuels. Why? Give reason, because consumption of fuel enable cars to move. And we need to eat food. Why? Give reason, because consumption of food enables body to carry out different activities. Slide 3. Sorry. Let's talk about work. When force acts on a body to move a distance in the same direction of force, it's said that work is done on object. And now, if the distance increases, the work done increases, as we see in this picture. And if you push a wall with your own hands, the wall will never move. That calls that the displacement equals 0 and no work is done. Slide 4. The work, this equation, we can see that work, and it represented by W, is equal force multiplies by displacement. Force is represented by F and displacement by D. The measuring unit of work is joule, the measuring unit of force is Newton, and displacement is meter. And from this equation, we can see three relations. We can find the work by multiplying force times displacement, and we can find displacement by dividing work over force, and find force by dividing work over distance. We have a small problem here. Calculate the work done when a force of 65 newtons acted on a body to move it to a distance of 10 meters in the direction of force. Solution. We know the equation of work equal force times displacement. Now it equal 65 times 10 equal 650 joules. Slide 5. We'll talk about resources of energy. The sun, it's the main source of energy or the permanent source. The wind, the fuel, the food, movement of water such as in waterfalls, and nuclear reactions. Slide 6. Forms of energy. We have too many forms of energy. At first we have light energy, and it produced from the sun, electric lamps, kerosene lamps. And we have sound energy that produced from loudspeakers, musical instruments. Third, electric energy, as energy produced from wind generator and solar cells. Chemical energy, and that stored in food, car batteries and fuel. Slide 7. Heat energy, as energy produced from heater, oven and burning of wood. Nuclear energy, as energy produced from the reactions in the nucleus of an atom. Mechanical energy or potential and kinetic energy. It's stored in stretched springs and waterfalls. Slide 8. Now we'll talk about the potential energy. Potential energy is the energy that is stored in the object due to the work done on it. And we have two factors affecting the potential energy: weight of the object and the height of the object from the ground. First, the weight of the object. As we see in this activity, we have some balls, and we will see the effect of weight on potential energy. Our steps: bring 4 identical balls and let them on the ground. Then we will lift one ball from the ground to the table, one by one. Then we will lift 2 balls from the ground to the table. Third, we will lift 3 balls and 4 balls. Observation: we will see and find that the work done to lift 1 ball is smaller than 2 balls, smaller than 3, smaller than 4. So the work done to lift balls increases by increasing the weight of the balls. Slide 9. We have a conclusion that the potential energy stored in an object increasing by increasing its weight. The weight, as we know previously, equal mass time acceleration due gravity. And weight, its measuring unit is Newton, mass by kilogram, and acceleration due to gravity is meter per second power 2. The acceleration of gravity due to gravity equal 9.8, approximate 10 meter per second power 2. Second factor affecting the potential energy is the height from the ground. We have a small activity. We will have a basin filled with sand and some metallic balls. And we will raise one ball half meter high and let it fall in the basin. Then I repeat the previous step by increasing the height of the ball. Observation: the metallic ball makes a print on the sand and becomes deeper by increasing the height. Slide number 10. Conclusion: the potential energy increases by increasing the height. Potential energy of an object is directly proportional to its weight and height. Potential energy, we have a small law here, potential energy, and it represented by PE equal weight times height, and Newton and meter. We have three relations here. Potential energy, we can find it by multiplying work times height, and height we can find it by dividing potential energy over weight, and we can find weight by dividing potential energy over height. We have a small problem. Calculate the potential energy of an object whose mass is 2.5 kilograms and its height from the ground is 4 meters. Solution: first we should write the law. Weight equal mass time acceleration due to gravity. We don't have the weight in the problem, we only have the mass. So first I should have the weight before I find the potential energy. Weight equal m times g equal 2.5 times 10 equal 25 Newton. Now we will calculate the potential energy. Potential energy equal weight times height equal 24 times 4 equal 100 joule. Slide 11. Kinetic energy. It's the work done during the motion of an object, and we have two factors affecting the kinetic energy: mass of the object and the speed of the object. First, the mass of the object. If two cars, one has a larger mass than the other, and the two cars are moving at the same speed, the work done to stop the larger mass increases, the work done to stop the car by the larger mass is bigger than the work done to stop the smaller mass of the car. Second, speed of the object. If we have two cars have the same mass and one of them is moving in a higher speed from the other, so we have to do more work to stop the car with high speed from the other car. Slide number 12. Kinetic energy of a moving body is directly proportional to its mass and square of its speed motion. We can see this in this relation. Kinetic energy equal half mass times speed power 2. Speed we represented by V, velocity power 2. So we can find kinetic energy by multiplying half mass times velocity power 2. Or we can find velocity power 2 by dividing the kinetic energy times 2 divided by mass. And also we can find mass by dividing 2 power kinetic energy over velocity power 2, And we can find that potential energy is maximum at the highest point, while it equals 0 at the ground. And kinetic energy is maximum at the ground, while it's 0 at the maximum height. Slide number 13. We have a problem. A racing bike is moving at a speed of 20 meters per second. Calculate its kinetic energy, knowing that the mass of the bike is 8 kilograms. Kinetic energy equal half times mass times speed power 2. So half times 8 times 20 power 2 equal 1,600 joules. Slide number 14. Mechanical energy. What is the mechanical energy? It's the sum of both potential energy and kinetic energy. Or we can say that mechanical energy equal potential energy plus kinetic energy. We have a small activity here to show the conversion of potential energy into kinetic energy. Steps: raise a tennis ball up to your hand level and lift it down to the ground. Observation: The ball moves continuously up and down after it's falling. Explanation. On raising the ball, potential energy stored in the ball. When the ball is left to reach the ground, the potential energy is converted into kinetic energy. Slide number 15. Now we can know that potential energy is converted into kinetic energy and vice versa. When object falls down, the height decreases, so its potential energy decreases because the potential energy affected by the height from the ground. And its speed increases, so its kinetic energy increases. Slide number 16. Questions on this lesson. Write the scientific term of each of the following. Number 1, the ability to do work or to make a change, energy. Number 2, the measuring unit of energy, joule. Number 3, the stored energy in an object due to work done on it, potential energy. Number 4, the work done during the motion of an object, kinetic energy. Number 5, the sum of the potential energy and kinetic energy of an object, mechanical energy. Now we finished this lesson. See you next lesson.